In lesson 2.2a, we're going to continue evaluating expressions. But in this case, we're going to be evaluating logarithmic expressions. And taking a look at the tips and tricks and cautions when evaluating a logarithmic expression. But before we do that, the next slide we're going to take a look at, we're actually going to take a look at what our calculator can do for us to help us not round an answer until the very end when we're looking for decimal approximations. So one of the things I want to start this lesson off with is making you aware of something that your calculator can do that helps us with the whole idea of rounding and making sure we're not rounding until the appropriate time. So for instance, let's say I've got a calculation where I need to do 8 plus 9. 8 plus 9 is 17. And then let's say I need to multiply, or rather divide that number by 36. Notice that I just hit my division symbol and it's taking the 17 and storing it as ANS. What that means is answer. So whatever the last answer you got is, if I use one of my operation symbols, division, multiplication, subtraction, addition, it'll automatically pull that, and now I can just type in 36 and it'll take the answer of 17 and divide by 36. I could keep doing that. If I need to then multiply this number, the 0.472222 repeating, if I need to multiply that by, let's say, 8, I don't have to type this in or do a decimal approximation. I can just hit my multiplication symbol and it's going to take that answer and I can multiply by 8. What this does is it allows us to do calculations continuously until the very end so that we're not rounding off any decimal place until the very end. Because in this week's homework packet, what you're going to find is that we're not going to get exact solutions, we're going to get decimal approximations. But we want to make sure that we're not rounding off until the very end. And so our calculator's ability to do this, to take an answer and then perform another operation on it, allows us to keep all of the decimals until the very end. So let's take a look at our first examples of evaluating logarithms and consider the first thing that we need to be concerned with. This first example right here says evaluate log of 3x plus 2 at x equals 49. Now, from what we know and what we've seen already, notice that this log does not have a base value listed. Well, what do we know the base value is when there's nothing there? We know that the base value is a 10. And it's important to remember the base value right here is a 10 because nothing is listed. Now, here's the point at which parentheses next to a logarithm are going to become very important to us, because it says that we're supposed to evaluate the log of 3x plus 2 at x equals 49. So it makes sense then the first thing we should probably do is we should probably plug in 49 for our x value here. So we're going to go log of 3 times 49 plus 2. Now here's the big question. After I do the 3 times 49, which we end up with 147, I have the log of 147 plus 2. So the question is this: do I do the 147 plus 2 first, or do I figure out what the log of 147 is first? And the answer to that question is I figure out what the log of 147 is first and then add 2. For one reason, because of the lack of parentheses. Because of the lack of parentheses, okay? The second you have a plus sign or a minus sign after a logarithm, it shuts off the logarithm. So everything after the plus sign is on its own. The only way that the plus or minus piece is a part of the logarithm is if you see in this second example that we'll get to in a minute, the 2x plus 18 is all in parentheses connected to the logarithm. Okay? But that's in contrast to our first example here, where we don't have that. So we need to figure out what the log of 147 is, and then whatever that is, add 2 to it. Now from your calculator, we've got an image of the calculator right here. What I want you to notice is next to this number 7 right here is the log button. Okay, we have a logarithm button in our calculator. So all we're going to do in our calculator is we are going to hit log, so hit that button in your calculator and type in 147 and close the parentheses. So I'm going to type it in as log. This will come up, and I'm going to do 147 close parenthesis. And when I do that, I get approximately 2.167317335 ... Right? Now, from the previous slide, what we're going to do is this. We're not going to round this number off because we can simply use that number again. So in your calculator, with that number achieved after doing the log 147, all you have to do is hit your plus sign, and it'll take this value, and then we're going to hit 2. So it's going to take that value and add 2, and that'll end up giving us 4 point, and I'm going to round to 2 decimal places, 17. 4.17 is that equation evaluated, or that expression evaluated at 49. So let's contrast that with this next one right here. I've got the log of, we've got 2 times 121 plus 18. So that's the log of, now in this case I am going to do the plus before I evaluate the logarithm, because all of this is in the parentheses next to the logarithm. So I'm going to go 2 times 121 plus 18, and I end up with 260. So now all I have to do is evaluate log of 260. So I'm going to hit my log button, 260, and I end up with 2.41. Rounded off to 2 decimal places, 2.41. So pay attention to those parentheses and make sure you're cutting the logarithm off when you need to, and only involving the things in the logarithm that should be involved in the logarithm. So one of the issues that comes up when evaluating a logarithm in your calculator is what happens when the log is not log base 10, otherwise known as common log. For instance, we have this example here of log base 3 of x minus 5 plus 6, and we're supposed to evaluate it at x equals 72. Okay. So this log button down here that we've taken a look at is your log base 10 and log base 10 only. Okay. However, if you have a newer TI-84, you actually have a function in your calculator that allows you to do different base values. So you want to start by hitting your math button. Your math button is right underneath alpha, which is right underneath the second button. And in the math, once you hit that, this column of information comes up, and if you scroll all the way down past 890 and then to A, if you scroll down, you see this one that says log base. If you hit enter on that and select it, this is what appears. What's nice about that is it allows you to input a base value, and then it allows you to input what you're taking the log of. Okay? So that's going to help us out since we have log base 3. So let's evaluate this. We've got the log base 3 of, in parentheses, I've got 72 minus 5. And then outside the parentheses is the plus 6. So is the minus 5 a part of the logarithm? Yes, it is, because it's in the parentheses next to the logarithm. Is the 6 part of the logarithm? No, it's not, because it's not in the parentheses. So we essentially have log base 3 of, let's see, 72 minus 5 is 67. And then our plus 6. So in my calculator, I'm going to hit the math button, and I'm going to scroll down to that option for log base, and I'm going to input a 3 for the base value, and then a 67 for what I'm taking the log of. and I end up with approximately 3.827276 ... But then I have to add 6 to that still. So with that number in my calculator, I'm just going to hit the plus sign, and it's going to take that answer right here that I got, and I'm going to add 6 to it. And when I do that, I get 9.83 when I round it to 2 decimal places. Now, the issue is this. What if you don't have a TI-84 with the ability to do log base? If you've got an older TI-84, or if you're using a TI-83, we've got other things to talk about in regards to how to evaluate a logarithm that has a base value other than 10. We have to use what's called the change of base formula. So what we're trying to evaluate is log base 3 of 67. Unfortunately, in the TI-83, you only have log base 10 right here. Okay, we only have log base 10. So how do we evaluate this? We use what's called the change of base formula. Here's how we're going to type it in our calculator. We're going to hit our log button, and in the first log, we're going to write 67. And then we're going to close that parenthesis off. Okay, so we've got this logarithm in our calculator. Don't hit enter yet. What you're going to do then is hit your division symbol. Okay, you're going to hit your division symbol, and then you're going to hit log again. But this time in the logarithm, you're going to put the base value, because right now log 67 is log base 10 of 67, but we want log base 3 of 67. So this second logarithm, log base 10, we're actually going to put a 3 in there. And the way logarithms work is, if you do a log base 10, but you divide by the log base 10 of the base value that you want, you'll end up with the same exact thing. So if we do log of 67, close that parenthesis off, like we have here, hit our division symbol, do another log of our base value, in this case it's that 3, notice we end up with 3.827276 ... just like we did right over here. And then with that number, all we have to do is add 6 to it, and we end up with 9.83 again, just like we did over here. But the trick there is this, using what's called the change of base formula, meaning we have to do 2 logarithms divided by each other. The bottom one is the log of the base value of interest. So this example is just to illustrate how we have to be careful when we've got multiplication and division involved with a logarithm. So we've got 4 times the log base 6 of x minus 18 all over x minus 123. We're supposed to evaluate it at x equals 153. So for us, that's 4 times the log base 6 of 153 minus 18 all over 153 minus 123. Now what I'm going to do to make this doable in my calculator is I'm going to evaluate this piece inside the logarithm and then underneath here first, because I know they're going to be integers. So it's going to end up with log, or 4 times the log base 6 of, see, 153 minus 18 is 135. Divided by, I've got 153 minus 123, and that's a 30. The reason I do that is, once I evaluate this logarithm, I know I'm going to end up with a nasty decimal. So with that decimal, all I have to do is hit times 4, and then whatever that is, divide by 30. So that's what I'm going to go ahead and do in my calculator. I'm going to figure out log of 135 with a base value of 6. Now, depending on whether you have the 84 or the 83, you're going to do that differently. But when you do the log base 6 of 135, you end up with approximately 2.73768 ... all over 30. So with that number that I got after evaluating that logarithm, I'm simply going to hit my multiplication symbol and 4 so that I multiply that number by 4. and then then I end up with a 10.9507 dot 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 all over 30. With that number still stored in my calculator, all I'm going to do is now hit my division symbol and 30, and I end up with 0.37 when rounded off to 2 decimal places. Again, notice I'm not rounding anything until the very, very end. Our last example here, where we're looking at tips, tricks, and cautions of evaluating logarithmic expressions, is going to consider this idea of the natural logarithm. Now we remember that a natural logarithm is log base e. Now e is a special number that you don't know exactly the context of it yet, but you do know that it is a number, not a variable. But we write log base e as ln with a natural log, ln, like right here. And what's nice is a TI-83 and a TI-84 both have an ln button. It's right underneath your log button. So we don't do much different other than hit ln instead of log. So in this case, we have 5 plus the natural log of, here we go, 81 in for x plus 7, and all of that's divided by 12. So we'll do 5 plus, and I'm going to actually enter that in my calculator as 5 plus the natural log of, really quick, 81 plus 7 is 88. So in my calculator, I'm going to type in 5 plus, hit my ln button, 88, close the parenthesis. 5 plus, hit the ln, the natural log button, 88. And when I do that, I end up with 9.477336 dot 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 dot, goes on and on. But I have to remember that this is still divided by 12. But with that long decimal still stored in my calculator, all I'm going to do is hit divide by 12. And I end up with 0.79 when rounded off to 2 decimal places. So you don't do it any differently. And know that you can input multiple things at once in the case right here. And that natural log button is just right under your log button.